All right, let's take an example. Look at example number 3. It says find the area of the region bounded by the graph of y equals x squared minus x minus 2 and the x-axis. Well, the first thing I want you to do is find the area of the region bounded. So it's the area of the region bounded. We want to do the integral from a to b of the top function minus the bottom function. Issues here. What's the top function? What's the bottom function? What's a? What's b? These are all questions that we need to ask. Well, I do know one of the functions is y equals x squared minus x minus 2. The second thing is I need to know what the x-axis is. Well, the x-axis is the horizontal line, y equals 0. So my second function is y equals 0. So my two functions are x squared minus x minus 2. My second function is 0, or y equals 0. Again, we're not given our limits of integration here. We don't know what a and b are, so to find those limits of integration, we need to set those two functions equal to each other and solve. So in this case, we're setting x squared minus x minus 2 equal to the second function, which is 0, and solving. Okay, we need two numbers. Well, you could use the quadratic formula. This is a quadratic equation here. So you could use the quadratic equation. I need two numbers that multiply to be negative 2, add to be negative 1. I'm getting x minus 2 times x plus 1 equals 0. I'm going to always double check when I factor. I'd have x squared plus x minus 2x, which would give me my minus x minus 2, so I did factor properly. I have x minus 2 equals 0, which gives me x equals 2. I have x plus 1 equals 0, which gives me x equals negative 1. So it seems like my first limit of integration is going to be negative 1. My upper limit of integration is going to be 2. So I know I'm going to do the integral from negative 1 to 2 of the top function minus the bottom function with respect to x. The question then being, though, which is the top function, which is the bottom function? So the way that we find which is the top function, which is the bottom function, is we need to plug in an x value in the interval into each of the functions. So the first function was x squared minus x minus 2. The second function that I need to plug into is quite simply 0. Okay, pick any number in between the interval, negative 1 to 2. Again, my trusty value to plug in is always 0. 0 squared minus 0 minus 2 is negative 2. And if I plug in 0 into the function 0, of course I get 0. No matter what x value I plug in, I get 0. So it seems to me that the top function is going to be y equals 0, and the bottom function, because it's a smaller number, the bottom function is going to be x squared minus x minus 2. Again, the higher number, higher y value is the top function, the lower value is the bottom function. So when I do the integral, go back to the original problem, when I want to find that area of that region, I have the integral from negative 1 to 2, my limits of integration, the lower minus the upper. I need to do the top function, which is 0, minus the bottom function. Make sure you put this in parentheses. This would be the x squared minus x minus 2. That's my bottom function. I integrate that with respect to x. Well, I'm going to clean that up a little bit by distributing the negative. So I have the integral from negative 1 to 2. It would end up being of negative x squared. It would be a positive x and a positive 2 from distributing the negative with respect to x. Now I integrate each term. The integral of negative x squared is negative x cubed over 3, or 1/3 x cubed. The integral of x is x squared over 2, or 1/2 x squared. And the integral of 2 is 2x. Again, I don't need my plus c because I am evaluating this from the numbers negative 1 to 2. I go ahead and I plug in each one of those numbers. I plug in the top limit minus the bottom limit. So here I'd have negative 1/3 times 2 cubed plus 1/2 times 2 squared plus 2 times 2. That's me evaluating it when x equals 2. I need to subtract off, make sure you use parentheses. I'd have negative 1/3 times negative 1 cubed plus 1/2 times negative 1 squared. Then I'd have plus 2 times negative 1. I use parentheses. Be extremely careful. I want you to plug this into your calculator yourself. Some of the biggest errors made are just evaluating this on the calculator. Do it one part at a time if you need to. Get your fraction. I'm getting 9/2. Please double check my work. I could have made an error in my calculator, but that's the value that I'm getting. So again, I just wanted to show you what the heck did we just do? What was the point of that problem? Well, if you graphed y equals x squared minus x minus 2, you would have ended up with something that looks like this right here, where you have a parabola opening up where it has x-intercepts of x equals -1, and it also has an x-intercept of x equals 2. And then what we did was we found the area bounded by that graph in the x-axis. If you notice on the interval -1, that should say -1, from -1 to 2, that x squared minus x minus 2 is the bottom function, and the x-axis, which is y equals 0, was the top function. So we just found the area of that shaded regions without having to look at the graph. Again, you should be kind of excited about this because we are now able to find the area of a shape that looks nothing like anything we found the area of before. We can literally find the area of any shape now as long as we know what functions represent the curves. Okay? Let's move on to example 4 here. I do want to warn you, this is an involved example. This is a little more difficult. One of these could be on the test, but it will take a lot of work for you to get these problems. So it says, find the area of the region bounded by the graphs of f of x equals x cubed plus 2x squared minus 3x, and g of x equals x squared plus 3x. So we want to find the area of the region. Area tells me I'm integrating. Region bounded by tells me I'm going to be doing the integral from a to b of the top function minus the bottom function. So what do I have? I have two functions. I don't know which one's the top function. I don't know which one's the bottom function. And I don't even know my limits of integration. So the first thing we need to do is find those limits of integration. How do we find those limits of integration? You find the limits of integration by setting the two functions equal to each other. So I have x cubed plus 2x squared minus 3x. I set that equal to the second function, which is x squared plus 3x. This is actually a cubic function, so we need to do some work. I'm going to subtract x squared from both sides, I'm trying to set this equal to 0. So I subtract x from both sides, and I also subtract 3x from both sides. When I do that, let's see what happens. I'm going to have x cubed, I'm going to have plus x squared minus 6x equal to 0. I look for anything in common. It looks like each one of these terms have an x in common, so I can factor out an x. If I factor out an x, I'd be left with x times x squared plus x minus 6 equals 0. I'm going to factor it even further because that inside the parentheses is a quadratic. I need two numbers that multiply to be -6. Those same two numbers need to add to be +1. Looks like I can do an x plus 3 and an x minus 2. I just want to double check that real quick. I'd have x squared minus 2x plus 3x would give me my plus x. 3 times -2 is -6, so I did factor that properly. Excellent. So what am I having here? I have x equals 0. I have x plus 3 equals 0, which gives me x equals -3. And then I have x minus 2 equals 0, which gives me x equals 2. X equals 2 is what I'm looking at. Okay, so this gives me a bit of an issue. Now I have -3, I have 0, and I have 2. So those functions are equal at those 3 points. So the point is I'm going to be integrating two separate areas. I'm going to have my first integral be from -3 to 0 of the top function minus the bottom function. Then I'm going to have plus, and I need to do my second integral from 0 to 2 of the top function minus the bottom function. So I've got to be very, very careful here. I'm actually doing two separate integrals, and I need to see which one's on top and which one's on bottom during both of those integrals. Okay, so I actually need to plug in two x values into each of these functions. Again, the first function was x cubed plus 2x squared minus 3x. The second function was x squared plus 3x. I'm going to be picking a point in the first interval from -3 to 0. So I'll plug in -1. I need to plug into both of them. I'm going to plug in a second number in the interval from 0 to 2. I'll plug in the number 1 into both of those. And I want to see what values I get. So I'm using my calculator here. Table feature is really nice to use. When I plug in -1 into the first function, I get a 4. When I plug in a -1 to the second function, I'm getting a -2. So it seems in the first integral, in the first interval from -3 to 0 that the top function is x cubed plus 2x squared minus 3x, and the bottom function is going to be x squared plus 3x. So I'm going to go back up to the integrals where I set it up. The integral from 0 to 3, when I do the top function, I need to have x cubed plus 2x squared minus 3x, and then I have to subtract off the bottom function, which was x squared plus 3x. I do that with respect to x. That's my first integral. Let's look at that second interval. The second interval, I plugged in 1 into both functions. When I plugged a 1 into the first function, I ended up getting a 0. When I plugged in a 1 into the second function, I ended up getting a 4. So the top function in the second interval is x squared plus 3x, and the bottom function in the second interval is x cubed plus 2x squared minus 3x. Okay, so what does that mean? That means when I do the integral from 0 to 2, the second interval, I need to do, the top function would be x squared plus 3x, minus the bottom function in this case was x cubed plus 2x squared minus 3x. So this is two complete separate integrals that I'm doing. I'm going to try to clean these up by distributing the negative, combining like terms, and writing them in descending order. Let's see what we get if we do that. So the first integral would be the integral from -3 to 0 of, what would I have? Well, I'd have x cubed, then I'd have a plus 2x squared minus x squared, which would give me plus x squared, and then I'd have a minus 3x minus a 3x, which would give me that minus 6x. Again, I just distributed the negative and combined like terms. Let's look at that second integral. That would be 0 to 2 of, well, let's see here, in descending order, it would be negative x cubed. I would have an x squared, and then I'd have a minus 2x squared, which would give me a minus x squared. I'd have a 3x minus a negative 3x, which would be a 3x plus 3x, so I'd have plus 6x. And all of this is with respect to x. Let's integrate both of these. The integral of x cubed would be 1/4 x to the 4th, plus the integral of x cubed would be 1/3 x cubed. The integral of minus 6x would be minus 6x squared over 2, which would simplify to a minus 3x squared. Again, this is evaluated from -3 to 0. I love seeing that number 0. I know when I plug it in, I'm going to get a 0, but let's continue on. Again, the integral of negative x cubed would be negative 1/4 x to the 4th. The integral of x squared would be negative 1/3 x cubed. And the integral of 6x, again, would be 6x squared over 2, which simplifies to plus 3x. Again, we are evaluating this one from 0 to 2. So we're going to plug in our upper limits minus our lower limits. We have a lot of parentheses here. We have, we're always doing the top number minus the bottom number. We got to be really, really careful. The beautiful thing is, once again, with definite integration, anytime I plug in the number 0, because each one of these terms has an x in it, I immediately get a 0. So the first function I have 0 minus, now I need to plug in that -3. So it's going to be 1/4 times -3 to the 4th plus 1/3 times -3 cubed minus 3 times -3 squared. That's what I'm getting at when I evaluate that first function, or that first integral. Plus, now I need to evaluate that second integral. So I'm going to have -1/4 times 2 to the 4th plus minus minus 1/3 times 2 cubed plus 3 times 2. That's what happens when I get that first number plugged in. And then again, the beauty of this is I'm plugging in the number 0. So I'm going to be subtracting off 0. When I plug in 0, I get a 0. I'm going to put all of this into my calculator. I want you guys to be really, really careful here. Lots of parentheses, lots of negative signs. Be very careful. Plug it in. Please make sure I didn't make an error because I easily could have. I'm getting a total of 253 twelfths. That might be off if I put it in my calculator wrong. Please check my signs. Please double check all my work, but that's what I'm getting.